Welcome to Technology Update and welcome to MAKS, the world-famous Moscow Air Show, where the planet's premier aerospace pioneers have come to show off their latest high-flying hardware. It's a biannual opportunity for the best of the best to soar above the rest at the legendary Zhukovsky Airfield in suburban Moscow region, the very place named after an early Russian aerodynamics genius. This year was the 10th time around for this festival of flight since its start in 1993, with over 800 companies representing 30 countries. The biggest draw for the air show's more than 500,000 guests was surely the in-flight action, but business was also on the bill, racking up some $10 billion in deals. Even with all the international big shots bringing their wares, Russia's open secret made the biggest buzz. The Sukhoi Pakfa T-50 finally broke out from behind the closed doors covering its development, flying for crowds and cameras for the first time. It's a fifth-generation stealth fighter to propel Russia's Air Force deep into the 21st century. Each MAKS sees new headlines and highlights, like the Sukhoi Superjet in 2009. But 2011 is already a new decade, with new projects like a whole batch of Ilyushin cargo and passenger jets in Russia's civil aviation pipeline. Undoubtedly the most notable newcomer is Irkut's MC-21, with the full-scale cabin model on display for the very first time. Its final boarding call for a glimpse to the future of this short and mid-range commercial liner. The single-aisle, narrow-bodied MC-21 is actually an emerging family with 200, 300, and 400 modifications forthcoming. They'll be capable of transporting anywhere from 150 to over 200 passengers per flight at a range starting at 3,500 to 5,000 kilometers, potentially up to 7,000 in the future. Cabin designs are easily transformable to increase comfort or capacity. The tall order to make these plans into internationally competitive aircraft rests on the shoulders of the Irkut Corporation. On the strength of over 75 years at its factory in the Siberian city of Irkutsk, the company hopes not only to bring in reinforcements for the aging domestic Tupolev 154 fleets, but also challenge the dominance of giants Boeing and Airbus in this market segment. Thankfully, they're not starting from square one, with a steady flow of skilled scientists and engineers from Russian aerospace schools making the project all the more promising.
We're designing this plane with a wide range of international partners. Inside Russia, this means working with research institutes for aerohydrodynamics, aviation materials and aviation technologies. Plus, the State Institute of Aviation Systems is helping design the airplane's digital components.
The MC-21 will be offered with engine options, either Pratt & Whitney's PW1400G or the specially designed new PD-14, a project of Russia's Aviadvigatel.
Our task is to provide the advantage of cheaper engines without compromising performance parameters and available resources. Most importantly, in terms of the life cycle cost as compared to our competitors abroad. It's important to point out that we're regarding this engine as the platform, on the basis of which engines will be designed for the whole line of these airplanes.
The PD-14 is projected to meet and exceed international standards on fuel consumption, emissions, and noise pollution. New engines are a start, but they aren't the only innovative rethink for the Irkut jets.
Our leading aerodynamics institute, TSAGI, made a crucial contribution to this project. Their experts produced a new concept for wing design. It has an altogether new profile for supercritical airfoils. All of their work helped greatly improve the plane's aerodynamics.
In addition to the supercritical design, the high wing aspect ratio on the wide-reaching airplane is a further aerodynamic advantage, but it's largely what the wings are made of that counts.
Here you can see a composite wing box for the MC-21 airliner. It uses unique advanced technology, what's called vacuum infusion, in a joint project between the main designer Aerocomposite and the Sukhoi company's design bureau on the Russian side, as well as Austria's Fischer and the materials supplier Cytec from the US. These materials and technologies have made it possible to improve the aerodynamic characteristics of the wing, reduce its weight, and as a result increase the airplane's fuel efficiency by up to 12%.
There are an awful lot of parts that have to fall into place for a passenger plane to break into the cutthroat commercial market. But the MC-21 is already taking its first strides into a sunny future. On board the prototype cabin at the Moscow Air Show, I could already get a feel for how a flight on the Irkut airliner might one day be. Automated latches open oversized luggage bins. spacious seats in both business and economy, and of course, a screen at every seat. As passengers, we're most concerned with smooth sailing to our destination, enhanced by every available amenity. But the carriers are all about the bottom line. All three MC-21 models allow for everything from spacious mixed-class layouts to the tighter tour operator scheme that makes the most out of every last row. In any combination, the airplanes will remain wider than traditional single-aisle jets, just enough extra aisle space to eliminate the annoying service cart squeeze by at drinks and meals time. Up front at the flight deck, pilots also enjoy every perk of 21st century aviation with multifunctional LCD output panels to integrate the latest in digitized flight controls. If only I had those pilot wings, I'd have had the thing runway ready. Obviously, this model's not exactly airworthy, but Irkut is planning production for the MC-21 by 2014, so there should be more progress to report at the next MAKS. This year's most triumphal entry went to the brand new, long-awaited 787 Dreamliner from Boeing, which had just wrapped up test flights for U.S. Federal Aviation Administration certification at its home base outside Seattle, Washington. With one of the 9 trial 787s freed up for a short getaway, MAKS visitors got a glimpse at the latest wide-body Boeing, billed as the company's most advanced, most fuel-efficient airplane ever. And with Russian flagship airline Aeroflot set to take 22 of the new Dreamliners, the 10-hour cruise from faraway Seattle gave future customers a good preview of what the modern machine is capable of.
It was a very enjoyable, easy flight. We used a lot of the automation on the airplane to make the pilot workload as little as possible. So the autopilot, of course, was used, the auto throttle was used. We just monitored those systems. The airplane is equipped with CPDLC and automatic position reporting and so forth, so we took advantage of all those things. We didn't have to make the standard position reports on the HF radio. The airplane's system did those reports for us. So very, very enjoyable flight.
Russia was hardly a random choice for the Dreamliner's visit, as Moscow is home to Boeing's biggest engineering office outside the U.S. The 11-hour time difference from the West Coast headquarters to Russia's capital means the company has round-the-clock engineering operations. With an aerospace tradition that grew up alongside and even at times ahead of the American and European schools, Russia provides a rich pool of specialists. That was a big deal in developing the Dreamliner.
If you think about the Russian contribution to this aeroplane, I think that I would say that materials and aerodynamics are two main areas where the partnership in Russia made it possible for me proudly to say that this aeroplane wouldn't happen without our Russian partners.
In terms of design, Russian engineers can lay claim to the nose cone structure that leads the 787 skyward. They pitched in on electrical systems and air conditioning. They designed the crucial leading edge of the wing that provides lift, the pylon for mounting the engines, and even added some flair to the passenger-friendly interior. When it comes to assembling airplanes, there are parts, and then there are parts. And it's largely thanks to unique new components that Boeing is promising a 20% bump in efficiency that could help the Dreamliner's operators cut $2.4 million per plane per year. This efficiency will be impossible without key parts like this body cord, connecting the wing to the fuselage, made entirely of Russian composite materials. The source of these all-important materials is Ural Boeing, a joint venture between the aircraft company and VSMPO Avisma, producer of fully a quarter of the world's titanium. It's at Ural Boeing in Russia's Sverdlovsk region that unique titanium alloys are turned into the backbone of the 787. Breakthroughs in material science achieved here are a major reason the world can expect lighter, stronger, more eco-friendly airplanes in the coming years.
We are now designing 787-9. That's the next modification of this aeroplane, which will be bigger, will carry more passengers, up to 280 passengers to a longer distance. That aeroplane is entering service in 2 years, and we're very busy designing this aeroplane. We also paid a lot of attention to the other very interesting project here in Moscow called 747-8. That project goes in parallel with 787 in certification and flight tests, and we will continue to work on the improvements of these aeroplanes. And I'm sure that there will be a lot of interesting projects, including the small aeroplanes that the Russian engineers will continue to help Boeing with.
For now, all eyes are on the upcoming commercial rollout of the first Dreamliners, due within the next month for delivery to Japanese carrier ANA. And that's just the beginning. Boeing racked up over 800 sales for their new standard-bearing jet before it even made its first test flight. So expect them soon at an airport near you. Not all of the newbies at MAKS are commercial jetliners, and for many of the far-flung, sparsely populated Russian regions, bigger isn't necessarily better. It's with an eye on regional small craft aviation that Rysachok has been developed, and it's already won attention at MAKS far greater than its size. The assembly lines at Samara's CSKB Progress helped put the first Soviet cosmonauts in orbit and propelled generations of air and spacecraft skyward over more than a half-century of its history. So it's an auspicious starting place for what will be the first post-Soviet small aircraft for serial production. Designed by engineers at Moscow-based Technoavia, it's intended to combine modern performance in avionics with the rugged all-condition reliability needed to serve Russia's regions.
The know-how of our designers can be seen in several solutions employed on this airplane. It has excellent aerodynamic properties, including the airfoil, ensuring great performance even at low velocities. Its landing gear is very good and allows you to land the aircraft on substandard airfields. The aircraft withstands strong winds very well. The asymmetric engines also offer very good power performance, which is particularly important for multi-engine aircraft and also is a significant advantage in trainer aircraft.
Before Rysachok flew in to take its place at the air show in Moscow, we got a chance to climb aboard for one of its certification testing flights in the western Russian city of Smolensk. The conditions at the former military airport are luxurious compared to the remote airstrips Rysachok is built to access. But it's a good base for monitoring and servicing the newborn aircraft while it gets its wings. In the field, it can take off and land from dirt, lift off with one of its two engines disabled, and provide crew and passengers with emergency oxygen if flight conditions demand a climb above 3,600 meters. Experienced test pilot Vladimir Makagonov whips the light airplane around curves. With performance parameters to establish, these trial flights are no relaxing puddle jump. But once it makes muster with Russian aviation regulators, the first batch are due for delivery to a flight school in Lenin's hometown, Ulyanovsk.
It really stands out for its modern flight control equipment, which in practice enables Air Academy students who've mastered this machine to transition easily to modern passenger jetliners.
When Rysachok hits the market, it won't just be raising a new generation of skilled pilots. It will also help revive an important aviation sector that suffered from post-Soviet economic belt-tightening and an aging fleet of light aircraft. With Rysachok and recent changes to airspace regulations, the range and flexibility of multi-purpose general aviation should be back on Russia's enormous map. The success of Rysachok and the potential for expansion in Russia's small aircraft sector has drawn the interest and the involvement of some of the country's biggest producers. That includes Salyut, makers of many a MiG engine, now at work on a domestically built engine for Rysachok. Both at their Moscow airshow display and on their assembly lines, Salyut is most distinguished for powering the sky's bigger beasts. In the Soviet era, their R-15-300 pushed the record-breaking MiG-25 Interceptor to unprecedented speeds and altitudes. Today, they're updating and repairing engines from the AL-31F family, the boosters behind a big chunk of the Russian Air Force's fighter fleet. From Sukhoi Su-27 to its descendants Su-30, Su-33, and Su-34. Salyut also collaborates with Ukrainian partners to power several large Antonov passenger and cargo planes, as well as the firefighting amphibian Beriev B-200. With all that under their belt, the company agreed to an order for what would become its first light airplane engine. How did Salyut come to the decision to expand from the production of engines for fighter jets into the arena of small aircraft?
The decision was made due to the existing need for a new engine in this class of aircraft, since the engines currently in use were designed back in the 1970s. Accordingly, it was quite obvious that the demand for a new engine will be high due to its improved technical and operational performance, as well as economic advantages resulting from the improved fuel consumption rates and enhanced engine power performance.
The turboprop TV500S consists of the reduction gear attached to the propeller, the combustor, the compressor, and at the rear the accessory gearbox. What's called the gas generator comprises both combustor and compressor, essentially the heart of the engine. The gas generator is the biggest piece yet produced in Salyut's project for the Rysachok turboprop engine. Along with it, they've developed a custom-made experimental stand to confirm they're bound for the appointed performance figures. Since Rysachok is already flying on the Czech-made Walter M601F and might see a replacement from General Electric, Salyut's TV500S needs specs to set it apart. Here we join Salyut's engineers to fire up the gas generator for another round of tests. Raw power is important, but not the only objective, given Rysachok's diminutive stature. A lighter, less powerful engine that still has the thrust to provide the desired cruising speed and takeoff distance, while guzzling less gas, is a more profitable formula. So far, 17 seems to be the engine's lucky number, projected to be 17 kilograms lighter than the Walter model and use 17% less fuel. Though it still just figures the TV500S is shaping up to be a highly competitive engine for small turboprop planes.
Technical solutions have laid a good foundation for the development of future engine. Right now we are talking about the gas generator, but we're hopeful to complete development of a new engine by 2012. From the outset, we've been developing our engine to complete the order from Techno Avia for the Rysachok aircraft project. It could be used in patrol flights, for example aerial monitoring of border areas, for the Emergencies Ministry's rescue fleet, for medical aid operations, and we expect it to be in good demand for light transport aviation.
Aside from frustrating journalists trying to make sense out of their piles of paper, wind is an ever-present variable in aviation for aircraft of all sizes. For generations, mankind has been playing and occasionally catastrophically losing a dangerous game with wind-shifting weather systems every time we take to the skies. Fortunately, now we're increasingly prepared with advanced equipment to keep us from getting blown away. Wind shear, where wind changes in direction or speed over a short distance, can quickly turn a smooth flight into a dangerous one. Given enough elevation, pilots can easily recover, but options are much more limited around takeoff and landing. That's why Russian scientist Mikhail Konevsky has developed technology to provide pilots and air traffic controllers with improved wind shear warning.
The atmosphere around airports is unstable. In some cases, airports have been built in places with complicated landscapes. Take, for example, Hong Kong, where roughly 1 in every 250 landings and takeoffs is performed under hazardous wind shear conditions.
Airports of the future will be fully covered with advanced sensor equipment to map out wind and other hazards, information that will help relieve congestion and increase throughput, a goldmine for the aviation industry. Old-school wind shear detection systems rely on anemometers, or simple wind gauges. The LiDAR Wind Profiler 300, developed by Russian firms Laser Systems and aircraft engineering concern, is ground-based, shooting laser beams skyward and then determining wind direction and speed by detecting the frequency of the backscattered light. At least in principle, one LiDAR Wind Profiler should give more detailed information over shorter distances, crucial around airports and low-flying aircraft, than several anemometers spaced out around the same territory.
The task is actually quite simple. Our device here will now measure the wind profile at an altitude of 300 meters. In the vicinity, you can see a tower with special platforms where wind gauges, like the one I'm holding, are installed. Our goal is to prove that the measurements of our LiDAR wind profiler correspond to the measurements obtained through the sensors installed on this high meteorological tower.
Against a whole host of spinning anemometers, just one scanning module on the LWP-300 is left to paint an equally accurate picture of the wind over this Kaluga region test site. The stakes are high, since the losing system may soon be consigned to the dustbin of aviation history. The physical benefits of replacing the towers in the already cluttered space around modern airports is obvious. Servicing the ground-based LiDAR systems would also be less of a challenge. But if the numbers don't back up the wind profiling benefits, then the towers are better left in place. Fortunately, the new technology performed perfectly and may soon be ready for full-time action.
The tests have been completed successfully, and most importantly, in the near future, we hope to get certified by the Interstate Aviation Committee, the organization that deals with equipment certification. Once we've got that, our task is to provide this equipment for Russia's first wind shear detection system and install it in Vladivostok, which will be hosting next year's major international summit. We should ensure maximum flight safety for the high-ranking guests and, naturally, all the commercial passengers flying to and from Vladivostok every day.
MAKS Edition 2011 features more than 10 American military aircraft, something unthinkable in Moscow when this air show first opened nearly 2 decades ago. The improved relations are thanks at least in part to a multinational treaty and high-flying surveillance technology. The story starts in the darkest days of the Cold War, when an arms race and mutual suspicion held the world, both East and West, in a state of great tension, ruled by the constant threat of all-out war and nuclear destruction.
What we're trying to do then is to relieve this great fear of surprise attacks. So now our allies and ourselves propose the inspection of all North America north of the Rio Grande and all of Europe in exchange for the same inspectional privileges of Russia and her satellites.
That was Eisenhower's main message at the Geneva summit of 1955, but Soviet and Western leaders failed to agree on a mutual inspection regime, and the idea was put on ice for a generation. It was reborn in 1992, however, as the Treaty on Open Skies. The United States and Russia were eventually joined by 32 other signatories. To date, they've completed more than 800 flyovers and generated both valuable data and a priceless boost in mutual relations. The Antonov An-30 and the Tupolev 154 have carried out most of Russia's flights to date, but like their counterparts in other countries, the planes are aging adaptations. The aeronautical and electronics equipment company Vega is responsible for bringing Russia's open skies surveillance capacity into the 21st century. Camera and sensor equipment allowed within the treaty has to be fine-tuned, like maximum ground resolution for photo and video material strictly limited at 30 centimeters. After years of work, Vega came to MAKS 2011 ready to unveil their brainchild. The first specifically built Tupolev 214 OS will be the most advanced aircraft in the history of the Open Skies Treaty.
This beautiful aircraft is not simply the first plane in Russia or any other treaty on open skies countries that incorporates all types of equipment allowed for use on board. It's also automated to a remarkably high level. The equipment is controlled electronically. All the data displayed on the screen where the operator monitors them. You are standing by the forward equipment bay of the aircraft, where optical electronic equipment is installed. And while the tail compartment contains airborne radars and the infrared camera, the best place on board the plane is reserved for photo and video cameras because we expect them to give us the main bulk of information. One fixed photo camera shoots directly below the aircraft, that one. Another one takes panorama pictures, plus 2 side view cameras and 3 video cameras. All this photo and video surveillance equipment enables us to cover a very large stretch of land and gives us a detailed picture of the landscape the aircraft passes over. Each photo camera has a separate optical port protected by sliding doors that are designed to prevent dirt from sticking to the lenses during takeoff and landing. Generally speaking, the equipment is very reliable and fully automated.
With the cameras and sensors installed in the plane's underbelly, crewmen and women on older planes operated them right from that tiny cabin. But the Tupolev 214 OS's move to remote control and automation lets the mission commander, the individual camera operators, and host country observers all sit comfortably in the passenger cabin above.
We're entering the compartment where the equipment operators sit. This is the key part of the plane, because this is where we receive the desired information. You'll notice that there are 2 additional seats located behind each operator's seat. They are for the representatives of the country the plane is flying over. This is a necessary provision aimed at exercising constant control over the treaty flights. Here is the equipment that operates the infrared camera and the radar. I should also mention that this is the first time in the history of the Treaty on Open Skies that surveillance radar has been installed on board an aircraft.
The Tupolev 214 OS is already flight-worthy and ready to fill all its treaty obligations. A second plane is on the assembly lines, set to join in the formal flights as soon as next year. International observers who came to MAKS agreed the plane is a big step to making sure the skies stay open well into the future. It's the end of an air show here in Moscow and the end of an era for Technology Update. I'm off to catch one of these jets back to the States, but the rest of the Tech Up team will be back next month with more from the ever-changing world of Russian innovation. Until then, enjoy the ride.